Let us solve for x in this problem. Given that 9 raised to power x plus 1 minus 9 raised to power x minus 1 is equal to 20. I'm going to change this power into 9 raised to power x plus 1, then minus 2, such that when you still add this together, you get this, and is equal to 20. The reason I've done that is that we can now separate this power into two separate powers, like 9 raised to power x plus 1 minus 9 raised to power x plus 1 minus 2 is equal to 20. And then we apply the law of indices that says when you have a raised to power m plus n, you can bring them together. These powers can be splitted onto a raised to power m times a raised to power n. If it is multiplication, this has to be addition. But because this power is negative, it means this n is negative. So it is already in this form, and our n is minus 2. So I'm going to write this as n 9 raised to power x plus 1, then minus 9 raised to power x plus 1 times 9 raised to power negative 2, and the result is still 20. So with this, we see 9 raised to power x plus 1 is common to the two terms here. So I'll factor it out as 9 raised to power x plus 1 into bracket 1 minus what is left here is 9 raised to power minus 2, then equal to 20. Let's tidy up the brackets. You have 9 raised to power x plus 1 outside, but in the brackets we have 1 minus 1 over 9 raised to power 2, then equal to 20. 9 raised to power x plus 1, 1 minus 1 over 81 is equal to 20. Let us find the LCM of the guys in the brackets. So we have 9 raised to power x plus 1 into brackets 81 minus 1 over 81 is equal to 20. Which is simplified into 9 raised to power x plus 1 times 80 over 81 is equal to 20. So I will express this as 9 raised to power x plus 1 divided by 81, then times 80 is equal to 20. The reason I've done this is because 81 can be expressed as 9 raised to power 2, and then we have 9 raised to power x plus 1 divided by 9 raised to power 2. I can go ahead and divide through by 80 here as well. If I divide both sides by 80, this gets rid of this, and this here is exactly 4. So I have 9 raised to power x plus 1 divided by 9 raised to power 2 is equal to 1 over 4. Applying the law of indices would give us 9 raised to power x plus 1 minus 2 is equal to 4 raised to power minus 1. If we tidy this up, this gives us 9 raised to power x minus 1 is equal to 4 raised to power negative 1. Let me break down 9 and 4 into 3 raised to power 2 and 2 raised to power 2 respectively. Then raised to power x minus 1 raised to power minus 1. So this gives us, opening the bracket, 3 raised to power 2x minus 2 is equal to 2 raised to power negative 2. At this point, I can then take the logarithm of both sides. So I have log 3 raised to power 2x minus 2 is equal to log 2 raised to power minus 2. Applying the law of logarithm that says I can transfer this power to the back. For those who don't know, if you have log a raised to power n, this can be expressed as n log a, simply transferring the power to the back of the logarithm to become a coefficient. This implies that I now have 2x minus 2 log 3 is equal to negative 2 log 2. We will then need to divide through by log 3. So that this can get rid of this. I have 2x minus 2 is equal to negative 2 log 2 divided by log 3. If I divide through by 2, this takes care of this turns this to 1, and this turns this to 1 as well. So I have x minus 1 is equal to negative log 2 divided by log 3. So that my x is now equal to 1. If I transfer this negative 1 to the other side, I have 1, then minus log 2 divided by log 3. This would be our final answer.